high into the atmosphere. The black dust finally settles on the white surface, leaving dark streaks. Back in the lab, Spencer recreates the spectacle.
So what we're going to do is put the nitrogen in a situation where it's contained within this flask, just as it might be trapped underneath a layer of glaze ice on Triton itself, and the pressure would build up, and that would produce a jet that could maybe shoot up 6 or 10 miles.
Just like...
Hey, we've got a geyser. All right.
Just as the pressure builds in the glass flask, on Triton, pressurized nitrogen, trapped under the surface, blasts moon dust into space. A world of violent geysers and crushing cold. With the right technology, humans could one day walk on the surface, but it's not a world we could easily colonize. Within our solar system, this is the end of the search. This far from the sun, any planet is cold and barren. After Neptune, there are only small, dead, icy worlds like Pluto. Beyond is the unknown. Out here, the possibilities are endless. And out here, perhaps we will one day find a place to call home. Today, astronomers are piecing together incredible new evidence in the search for distant worlds, planets that could support human life. Our sun is only one of 200 billion stars that make up our galaxy, the Milky Way. Any of these stars could have planets, just like our solar system. Tracking them down is the ultimate scientific quest, and king of the planet hunters is Dr. Jeff Marcy.
Our Milky Way galaxy is a glorious but enormous place. It contains 200 billion stars, and it's 100,000 light years across. And so we have to pick and choose which stars to observe.
This is the Lick Observatory in California, where planet hunters like Marcy come. He scans the night sky, searching for new worlds orbiting distant stars. But he has to pick carefully.
Luckily, there's this marvelous catalog called the Hipparcos catalog that has over 100,000 stars that are all very nearby. And what we've chosen, logically, are the nearest. In fact, the nearest 2,000 stars, they're all within about 200 or 300 light years of the Earth. So if you imagine the little Earth floating in the blackness of the universe, and you imagine a glass sphere extending out about 300 light years, we are observing and hunting for planets around those stars within that sphere. Okay, Bernie, I think we can go to the next star. The next one will be Barnard's star. Do you have the
Every star takes hours of painstaking observation.
1757.
Lick's 3-meter telescope locks on to its target. But even with all its magnification, a planet circling a distant star is too small and faint to be seen directly.
The real challenge in planet hunting is that planets, by their intrinsic nature, don't produce their own energy. They shine by reflected light, and if they're warm, they glow a little bit. But they are, in fact, about 1 billion times fainter than the host star around which they're orbiting.
So astronomers have perfected an ingenious technique to find these invisible worlds.
So we use a trick. And the trick is we watch the star, not the planet. As a planet orbits the planet pulls gravitationally on the star, making the star wobble to and fro.
To show how a planet pulls on a star, Marcy uses a simple demonstration.
Okay, so here we have a bag of rice, and it's going to simulate the planet, and I'm the star. And what happens, of course, is that the planet orbits the star like so. And as the planet orbits the the planet pulls back on the star and makes the star wobble. You might be able to see my body wobbling back and forth. And it's wobbling because, in fact, the sack of rice is pulling on me. And of course, the analog is quite perfect because the sack of rice acts as the planet, my body is the star, and this rope serves as gravity. And of course, all we see with our telescopes is the star. We can't detect the planet at all, so we just watch stars to see if they wobble to and fro. And if they do, they must have a planet.
To date, hunters like Marcy have found over 200 new planets orbiting distant stars. But can they determine what those worlds are like? Marcy believes so, by calculating how far the new world is from its star.
The longer it takes the planet to go around the star, the farther the planet must have been from the star. Close-in planets go around fast. Distant planets take a long time. The Earth, of course, taking 1 year.
He's discovered one world 1,100 times the mass of Earth that orbits 8 times closer to its parent star. Another planet is so close, it races around in just 3 days, making its surface thousands of times hotter than Earth.
Some of the planets we've found orbit so close to their stars that the temperatures are thousands of degrees. At those kinds of temperatures, ordinary metals like iron and nickel and titanium not only melt, they vaporize.
Instead of clouds of water, the atmospheres of these deadly worlds are filled with clouds of metallic vapor. But Marcy's convinced that not all alien worlds are so savage. He's decided to look at smaller stars that burn less intensely. Could their orbiting worlds be more like Earth?
What we hope to do in the next year is a glorious quest. We're going to observe low-mass stars and hunt for Earth-like planets. They're orbiting close, but next to a dim star, the temperature won't be too hot nor too cold, but just right for life.
Out here, countless worlds are waiting to be discovered. Perhaps some will have breathable atmospheres and oceans of water, allowing life to flourish. But finding them is a huge challenge. So far, scientists have drawn a blank. And judging by the deadly environments on the planets that make up our own solar system, it's not going to be an easy job. From the crushing heat of Venus, to the erupting volcanoes of Io, to the 1,400-mile-per-hour winds of Neptune, the worlds we have discovered are too savage for even our most advanced technology. The only planet that offers hope for human colonization is Mars. If we could overcome the dust and the solar radiation, one day we could live here. Maybe in the future, when Earth's climate is too extreme, Mars will become home. Until that day, humans will have to adapt, continuing to thrive in a constantly changing world.